Plotting linear graphs that have a limited range. At this point, we have to assume knowledge of two important concepts that will be explained in more detail in the Functions chapter. These are the concepts of domain and range. The domain is the set of all possible values the independent variable x can take, whereas the range is the set of the corresponding y values of the dependent variable. In other words, if the domain is limited within a certain region of the x-axis, this usually brings a limitation of the graph's line, which in return causes some limitation in the corresponding y values as well. In all examples considered so far, we have not mentioned any limitation in the variable's values, so the domain and range have both been from the set of real numbers R. Now, we will see what happens with a linear graph in situations where the domain has some restrictions. Let's consider a linear graph that is limited on both sides. If we denote the points that represent the endpoints of a limited linear graph as A and B, where A is the leftmost point, then the procedure followed to plot the graph if only the two limit values of the independent variable x are known, is as follows. Step 1. Substitute the two limit values x, a, and x, b in the line's equation. In this way, you will obtain the two corresponding y values of the limit points a and b. Step 2. Connect these points in the shortest way to plot the graph. For example, if we have the linear equation 2, x, minus 3, y plus 1 is equal to 0 limited within the points a and b, where the domain is, minus 2, 4, the corresponding y values that give the range of this line, for x, a, equals minus 2 and x, b equals 4, we have the following shown on screen. And we have the following shown on screen. Therefore, points A and B are the limit points of the graph. Another thing we discovered here is the range of the line, i.e. the set of vertical values it lies, represented by the segment. The interpretation of all the findings is as follows. The line extends horizontally between the coordinates x equals minus 2 and x equals 4, but not on the left of x equals minus 2 and on the right of x equals 4. On the other hand, the line extends vertically between the coordinates y equals minus 1 and y equals 3, but not below y equals minus 1, and above y equals 3. The graph of the line is shown in the figure. We have the following shown on screen. When plotting a linear graph with a limited domain and range, we make use of one of the main line's properties, which says that 2 points determine a single line. That's why it is sufficient to have just 2 points of a linear function in order to plot its graph. To avoid unnecessary operations, we choose these two values to be the limit values, which determine the domain and range of a linear function. Example. Plot the linear graph 3x plus y minus 2 is equal to 0 limited to 4 units only in the horizontal direction, by starting from the origin and moving due right. Solution. From the equation given in the clues, it is clear that we are dealing with a linear equation function graph. From clues, it is clear that the domain of the given line is the segment. Therefore, to plot the graph of this line it is sufficient to find the coordinates of the endpoints. Thus, denoting the endpoints by A and B, where A is the leftmost one, yields, we have the following shown on screen. Therefore, for the corresponding y values of the endpoints, we have the following shown on screen. And we have the following shown on screen. Therefore, we have for the given line the following data, we have the following shown on screen. Therefore, the graph that represents this line in the xy coordinate system is shown, we have the following shown on screen. That is all for lesson 14.1.5, and the end of tutorial 14.1. To continue this chapter please watch 14.2, Introduction to Slopes and Gradients. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.com.